Welcome back. On this tutorial you will learn how to create a power transformer in PSS-CAPE. My name is Carlos Beltran and I'm your instructor. Open the project that we created previously. It should be found where the recent files were opened. In this case it's this one. A pop-up window appears automatically with all graphic file information. It has been placed in as you can see. Make sure you select the radio button Keep Isolated Buses as to Energized. Also, make sure to select the Without Load Currents radio button. Then press the OK Build Short Circuit Network button. The network equivalent source can now be seen as a generator connected to the 230 kV bus. Let's hide the No Protection text that appears above the bus. It is not needed in this example. In order to hide the text, place the cursor over the text, and right-click to select Hide Text. Now let's model a 2-winding transformer. Place a second bus on the graphics area. CAPE automatically numbers this bus. Just click OK. This pop-up window appears where you must introduce the transformer's secondary bus voltage, or the nominal voltage of the distribution lines. The transformer's secondary's voltage is 36.2 kV, but you need to put the nominal voltage of the distribution line. Most transformers will have a voltage tap changer to match the distribution line's nominal voltage. Since the nominal distribution voltage of this project is 34.5 kV, I will introduce it to the base kV field. Since all data for the bus is now complete, click on the green checkmark button. Proceed next to hide the text above the second bus. Right-click and select Hide Text. Now let us place the transformer with its technical data as shown in the Excel sheet. This is a 37 MVA transformer, with 230 kV on winding 1 and 36.2 kV on winding 2. It is a delta Y transformer with positive and zero sequence impedances as shown in the Excel sheet. Now, select the transformer icon from the above menu. Notice that there are many types of transformers. Select the 2-winding transformer icon, because it is the one used in the project. A pop-up window appears. Click on Create a new transformer. The transformer library window appears requesting us to introduce transformer data into the red fields. The name of this transformer is T1_GYO. The transformer is manufactured by VEG. But for modeling purposes you may leave the question mark. It cannot be left empty. Disregard the middle white section. In the connection during testing fields, select Delta Closed for all tests under the primary designation. And select Y under the secondary circuit designation. Now add kV tap button and choose P for primary winding and type in 230 in the tap kV field that matches the transformer plate. Press OK. Add the secondary kV tap now. Here we introduce 36.2 kV that matches the transformer plate. Notice that the introduced voltages appears in the adjacent positive sequence tab. Now introduce the transformer power rating in the base MVA field. Next, introduce 12.12% as the positive sequence reactance as shown in the Excel sheet. Select %R and %X from as the impedance form, because we do not have transformer loss information. Leave %R as 0. Next, go to the Zero Sequence tab and introduce 11.98 in the Zero Sequence % reactance field. It is industry standard to give transformer impedances in percentages. Finally, select number 1 as the shared neutral group under the secondary Y winding. Since everything has been defined for the transformer, click on the green check button. The cursor appears. Follow its instructions by clicking on the 230 kV bus first and then clicking on the second bus. Then align the cursor between the two buses and click again. The transformer icon should appear between the two buses. However, we get an unexpected warning message. Click yes, so you don't lose information. Something is missing here. A pop-up window appears, and we can see that the equipment name is missing. Fill in the name in the given field. Type T1_GYO. In the neutral connection field of the Y winding, we see a -1. Click on it and select solidly grounded. CAPE will automatically put a 0 which identifies the neutral as solidly grounded. And a -1 on the delta means ungrounded. Notice the difference between grounded versus ungrounded. Okay, we could have filled the in-service date field, but it is not required in order to calculate short circuits. Now, click on the green check mark. In the following pop-up, click on the Rebuild Now button. The transformer connection is shown by a delta on the primary and a Y on the secondary. This line looks out of place. Select and drag the end of the line between the two buses. Now the one-line diagram of the transformer looks correct. Let's now verify that the connection of the transformer is correct by simulating a ground fault on the secondary side. There should be 0 sequence current for this fault. Let's go to the short circuit module. Before simulating the fault, it is recommended to save and reread while on the one-line module. Now let's go to short circuit. Place the cursor over the green bar. Right-click, select faults, and then single line to ground. In order to confirm this, we must look at the zero sequence. We select zero sequence, and this allows us to see the zero sequence. I can now certain that the transformer has been well modeled and I haven't forgotten to set Y as grounded. I'm going to clear all the faults now. Let's take a look at what would have happened if I had forgotten to do the grounding, and left this field as -1. Now let's run a ground fault simulation. Right-click on the bus, select faults, and then single line to ground. We can see there is no zero sequence current and no fault current at all. This was not expected. Let's correct this by grounding the transformer neutral connection. Double-click on the transformer. Correct the error by choosing solidly grounded in this field and press the green check mark. Now that the transformer neutral has been reconfigured as grounded, we can see the zero sequence current as expected. So now clear all faults into the one-line module. Click on Save and reread. This concludes tutorial number 2.